In section 11.3, we will look at surface area of pyramids and cones. A pyramid is a 3D figure in which one face, the base, can be any polygon, and the other faces, the lateral faces, are triangles that meet at one point, the vertex. Regular polygon is where the base is a regular polygon and the faces are isosceles triangles. A cone is pointed like a pyramid, but its base is a circle. Lateral area of a pyramid is half the product of the perimeter of the base and the slant height. So we can use the formula that lateral area equals 1/2 PL, where L is the slant height. So in our pyramid on the right, this is L, your height would be in the center. This would be your height. Lateral area of a cone is half the product of the circumference of the base and the slant height. So again, lateral area equals pi times radius times L, L being the slant height. So in a cone, here's our radius, this is our height, and then the side here is our slant height, or L. Pyramid and cone surface area formula is the sum of the lateral area and the area of the base. So remember, capital B is the area of the base. In number 1, we want to find the surface area of a square pyramid with base edges 7.5 feet and slant height 12 feet. Well, we first have to find the lateral area. So lateral area is 1/2 times the perimeter. So if it's a square, remember all the sides are the same, so there's 4 of them and they're each 7.5, and then times our slant height of 12. So lateral area equals 1/2 times 30 times 12, or our lateral area is 180 feet squared. Then to find the surface area, we just take our lateral area, which we found to be 180, plus the area of the base. Remember, it's a square, so our area will be length times width, or 7.5 times 7.5. So our surface area, 180 plus 56.25, or our surface area is 236.25 feet squared. Okay. In number 2, we want to find the lateral area of the hexagonal pyramid and round to nearest tenth. Well, in our example, we're given that our sides are 8 meters and that the height is 20 meters. For lateral area, we need to find L. We need our slant height. So first, let's find L. And you notice we have a right triangle here. So we can say 4 square root 3 squared plus 20 squared equals L squared, our slant height. 4 square root 3 squared is 48. Take 4 squared is 16, and then square root 3 squared is 3. 16 times 3 are 48. 20 squared, 400, so that gives us our slant height. Combining like terms, we have 448 equals L squared. Then take the square root, and rounding to nearest tenth, our slant height is about 21.2 meters. Okay, now we can find our lateral area. So remember, lateral area 1/2 times the perimeter. So a hexagon has 6 sides. they're each 8. And then times our slant height, which we found to be 21.2. So our lateral area, 1/2 times 48 times 21.2. And then simplifying, we get lateral area equals 508.8 meters squared. Number 3 says the Great Pyramid at Giza, Egypt, was built about 2580 BC as a final resting place for Pharaoh Khufu. At the time it was built, its height was about 481 feet. Each edge of the square base was about 756 feet long. What was the lateral area of the Great Pyramid? Okay, so we are given that we have a square base. Our sides are 756 feet long, and then our height is 481 feet. But we need the slant height in order to use our lateral area formula. So in our pyramid, we would have a right triangle. It says the height was 481. Now, the whole square base is 756. If I divide that in 2 to get the base of my right triangle, I get 378. And we want to find our lateral height, which is our hypotenuse. So if we take 481 squared plus 378 squared, we can solve for our lateral height. So squaring both numbers, we have 231,361 plus 142,884. Oops. Which, adding them together, we get 374,245. Then taking the square root to the nearest tenth, and get 611.8 feet. So that's our lateral height. Or I'm sorry, our slant height. So now we're going to find our lateral area, which will be 1/2 times the perimeter. So there's 4 sides. They're each 756 feet times our slant height, 611.8. So our lateral area will be 1/2 times 3024 times 611.8. And then rounding, we get 925,041.6, which is about 925,000 feet squared. So that's our lateral area of our pyramid. Okay, number 4, let's look at a cone. It says find the surface area of the cone in terms of pi. So first we need to find our lateral area. Lateral area will be pi times the radius, which is 5, times our slant height of 13. So lateral area in terms of pi is 65 pi inches squared. Then to find the surface area, we'll take our lateral area, so 65 pi, plus area of the base. That's pi r squared since it's a circle, so pi times 5 squared. So our surface area will be 65 pi plus 25 pi. So surface area, 90 pi inches squared. And for our last example, number 5, I think it should say Andrea. So Andrea uses paper cones to cover her plants in the early spring. The diameter of each cone is 1 foot and its height is 1.5 feet. How much paper is in the cone? Round to nearest tenth. So they told us our diameter is 1 foot and height is 1.5 feet. So if our diameter is 1 foot, our radius is half a foot, or 0.5 feet. Our height is 1.5 feet. We need to find our slant height, or L. So the height goes from our vertex of our cone to the base. So here's our cone. Our height being 1.5, radius being 0.5. We want to find L. So we have a right triangle here, using the Pythagorean theorem to solve for L. So 0.5 squared plus 1.5 squared equals L squared. And then simplifying, 0.25 plus 2.25 equals L squared. Combining like terms, we have 2.5 equals L squared. We're going to take the square root to solve for L. We get about 1.58 feet as our slant height. I'll fill that in over here. Now, if we want to know how much paper is in each cone, keep in mind it said she was going to cover her plants. So we want a cone that has an open base. So we're looking just for the sides of the paper cone. So that would be our lateral area, not the whole surface area. So our lateral area equals pi times our radius times our slant height. So lateral area equal to 0.79 pi feet squared, and it said to round to nearest tenth. So our lateral area is about 2.5 feet squared. So that's how much paper is in one of her cones that she's using to cover her plants.